This is a self-driving car, and it looks nothing like a real car. But for self-driving, all the same principles still apply. In order for the car to drive around, there has to be some sort of thing controlling the car. One way of doing that is to use a neural network. A neural network is a way to achieve a complex behavior that's also dynamic from a program. You could describe it as a digital brain. A neural network can be divided into 3 parts: inputs, outputs, and the middle. As for inputs, there are 16 sensors located around the car. They can measure distances to an object in front of them. As for outputs, we need to be able to control how fast the car drives and how much it turns. And for the final part of the brain that does the thinking, I ended up with 2 layers, each with 1024 neurons. You see the neurons have different colors. The color represents how hard a neuron is firing, and the thickness of these lines demonstrates how active the respective synapses are. Here it goes. You can see it drives around, the neurons are firing, and it crashes. Well, actually that's no surprise, since I haven't told the car what it should do. One thing I do know is that crashing is bad. So now when our car just have crashed, let's step back in time a bit and readjust the path so it doesn't crash anymore. Now let's train our neural network on this newly added data. And now if we run our model again, it doesn't seem like much has happened. But if you keep letting the car crash and steer away from the threats, the car will gradually become better and better, and eventually it will learn to drive. Something similar is actually used in real life too. You might have heard of Tesla and their full self-driving beta, which lets drivers test out their full self-driving system. When the car does something bad, the driver is supposed to take over and correct for the car. By doing this, Tesla will get information about what the car should have done. It might not be perfect, but at least it should be better than what the car actually did. There's one thing I haven't talked about yet. What is it the car actually sees? But first, earlier I described the neural network as a digital brain, but it's also a form of pattern recognition. Assuming that is correct, imagine you have a piece of paper in front of you. On this paper you can draw out where the car is. You also know where on the car the sensors are located and how far distances they measure. There are some lines between the points. There are some things that become quite clear. Both here on the left side as well as the right, you can see that there are some walls or something that we probably should stay away from. As well as there is an open area behind us. As well as in front there seems to be an open area that also continues to the right side. Based on these patterns, we can probably guess that this is a curve, which in fact it actually is. If you now look about 5,000 crashes into the future, and let the car drive. When the car is on a straight road, it seems to be favoring staying in the center of the road. And when the car seems to be approaching a corner, it likes to cut them. It gets a bit close to crashing sometimes, but that never seems to happen anymore. Anyways, I really do hope you will have a great rest of your day, and goodbye.